ఆల్కేన్ ట్రీటెడ్ విత్ KMnO4. సో జనరల్గా మనకి ఆల్కేన్తో నో రియాక్షన్, బట్ అకార్డింగ్ టు ఎన్సీఆర్టీ కోల్డ్ కండిషన్లో మనకి టెర్షరీ హైడ్రోజన్, సో టెర్షరీ హైడ్రోజన్ ఉంటే, సో టెర్షరీ హైడ్రోజన్ ఉన్న కాంపౌండ్కి KMnO4 యాడ్ చేస్తే మనకి టెర్షరీ కార్బన్ దగ్గర సింపుల్గా ఆక్సిడేషన్ జరిగి కరస్పాండింగ్ టెర్షరీ ఆల్కహాల్ ఫామ్ అవుతుంది. ఇట్ ఈస్ సింప్లీ ఆక్సిడేషన్ only at tertiary carbon. Now it is treated with Al2O3. So alcohol treated with Al2O3. Low temperature ether form అవుద్ది, high temperature alkene ఫామ్ అవుద్ది. లో టెంపరేచర్ ఈథర్ ఫామ్ అవుద్ది, హై టెంపరేచర్ ఆల్కిన్ ఫామ్ అవుద్ది. సో లో టెంపరేచర్లో ఇక్కడ క్వశ్చన్లో మనకి హీట్ ఇచ్చారు, హీట్ అనేది మెన్షన్ చేశారు. హీట్ మెన్షన్ చేశారు కాబట్టి ఎలిమినేషన్ జరిగింది. ఎలిమినేషన్, దట్ మీన్స్ ఇన్ దిస్ కేస్ డీహైడ్రేషన్. దట్ మీన్స్ ఇన్ దిస్ కేస్ డీహైడ్రేషన్. It is a alpha carbon, it is a beta carbon, it is a beta carbon. Therefore we get two types of alcohol, one alkene like this and another alkene like this. So you get two alkenes, and among these two it is a stable alkene. It is a stable alkene, therefore it is a major product. The reactant is epoxide. To epoxide we are adding lithium aluminum hydride. H minus is nucleophile, it is a hydride. H minus is nucleophile, and when H minus attack on the epoxide, it follows SN2 reaction. And for SN2 we know that general order primary greater than secondary greater than tertiary. It is a general SN2 reaction order. Therefore it is a secondary carbon, it is a primary carbon. H minus attack at this carbon, ring opening takes place. Therefore the structure of A, you can write this is a O minus above the plane and hydrogen, and this hydrogen coming from the LiAlH4. Now it is treated with acidification. Acidification means we are adding H plus to neutralize O minus. O minus take the proton and corresponding alcohol is formed. Corresponding alcohol is formed. So it is not chiral center. It is not chiral center. Therefore you can write simply without stereochemistry we can write. Without stereochemistry we can write. It is the first compound. Now second one is alcohol treated with PCl5. So we know that when alcohol treated with PCl5 through SN2 mechanism, we get corresponding alkyl chloride, POCl3 and HCl. Therefore here through SN2 mechanism, in place of OH we get corresponding alkyl chloride. We get corresponding alkyl chloride, and the side products are POCl3 and HCl. It is also nucleophilic substitution. Here the reactant is alkene, and we are adding electrophile. So this entire reagent is oxymercuration demercuration. This entire reagent is oxymercuration and demercuration. So when alkene treated with mercury compound, when alkene treated with mercury compound, so alkene attack on the mercury, leaving group will leave. It forms corresponding stable C. It forms corresponding 3-membered ring. Of course above the plane and below the plane. Now it reacts with nucleophile H2O. It is a primary carbon, it is a secondary carbon. Nucleophile attack at secondary carbon, ring opening takes place. So this overall reaction is electrophilic addition. This overall reaction is electrophilic addition. Now it is treated with NaBH4 through free radical substitution. In place of mercury, we write simply hydrogen. In place of mercury, we write simply hydrogen. So this is a oxymercuration, demercuration. Now it is treated with SOCl2. This compound name is thionyl chloride. This compound name is thionyl chloride. When alcohol treated with SOCl2, so we know the basic reaction. When alcohol treated with the SOCl2, it follow SNI kinetics and gives corresponding alkyl chloride, and we know that SNI mechanism follow retention in configuration. So similarly here, alcohol group is there and SOCl2, therefore corresponding product is corresponding alkyl chloride, SO2 plus HCl. So to convert alcohol to alkyl chloride, suppose HCl, PCl3, PCl5, SOCl2. We can use 4 reagents, but among these four, SOCl2 is best because one of the product is gaseous product SO2 and which releases from the container. As a result, reaction will be completed. Alkene treated with B2H6. When alkene treated with B2H6, this reaction is known as hydroboration. In hydroboration, more sterically hindered carbon, hydrogen, should be connected, and less sterically hindered carbon, boron, should be connected. Here we are connecting hydrogen and here we are connecting boron. This is hydroboration. Now it is treated with H2O2 and OH minus. Now here H2O2 react with the corresponding boron and finally we get OH group in place of boron. This is known as oxidation. And the overall reaction, syn addition. That means both hydrogen and OH will be attached from the same side. It is a primary alcohol. Now the alcohol treated with PbR3. So we know that the basic reaction, when alcohol treated with the PbR3, SN2 reaction takes place. In place of OH, we write simply alkyl bromide and PbR3 will be converted to H3PO3. So this is a basic reaction. So similarly here, it is a primary carbon. We are adding PbR3, SN2 reaction takes place and the corresponding product is, in place of OH, we can write Br and PbR3 will be converted to H3PO3. It is a ketone treated with H2PD. When ketone treated with H2PD, this reaction is catalytic hydrogenation. So in catalytic hydrogenation, so H2 will approach the ketone from the above the plane, from the below the plane. Therefore, we get corresponding products. OH above the plane. Suppose hydrogen attack from the below the plane. Now OH below the plane. Suppose hydrogen attached from the above the plane. So this is a catalytic hydrogenation. Now these compounds treated with HCl and ZnCl2. The general reaction is, when alcohol treated with the HCl and ZnCl2, secondary and tertiary follow SN1 mechanism Primary either SN2 or no reaction at room temperature. No reaction at room temperature. Therefore, corresponding product is alkyl chloride. So it is a general reaction which was discussed in the class. Similarly, here it is a secondary alcohol. It is also secondary alcohol. When secondary alcohol we are adding H plus, both molecules loses carbocation H2O, and finally they give corresponding carbocation. Both compounds will give the same carbocation. Losing the H2O molecule, losing the H2O molecule. Now of course here migration possible. Now we got carbocation planar. Now it react with the Cl minus. Cl minus attack on the corresponding carbocation, and it is a final compound. It is our final compound, alkyl chloride. So it is insoluble in Lucas reagent. Insoluble in Lucas reagent. So finally there is no stereochemistry because there is no chiral center. That's why I have written the molecule in a simple way without stereochemistry, without 3D. Neopentyl bromide. This molecule name is neo. 4-degree carbon is neo. Total 5 carbons. Neopentyl bromide. When neopentyl bromide treated with moist AgNO3, it's not AgNO3, slightly printed mistake, it is Ag2O. Moist Ag2O. So moist Ag2O means we should think simply AgOH. So in the presence of Ag plus, it loses Br minus and forms stable C plus. Even though it is primary, it forms stable C plus because of Ag plus and another supporting factor because of strong plus sign nature. Now once a C plus is formed, we have to consider migration. From here migration happened. Now it reacts with OH minus and corresponding alcohol will be formed. It is a tertiary alcohol. Now the tertiary alcohol treated with the copper heat, temperature generally 300 degrees Celsius. Copper heat 300 degrees Celsius. Suppose primary alcohol treated with the copper, it gives aldehyde. Secondary alcohol, if you treat with the copper, secondary alcohol treated with the copper gives ketone. Tertiary alcohol with copper, dehydration takes place. So tertiary alcohol ki dehydration possibility. Therefore in this case it is alpha carbon, beta carbon, beta carbon. So we expect two alkenes, one alkene like this and another alkene like this. So two alkenes are forming, and among these two it is a stable alkene. Therefore corresponding product is major. Alkene treated with cold alkaline KMnO4. Cold alkaline KMnO4. It is a Bayer's reagent. It is a Bayer's reagent. So Bayer's reagent treated with the alkene. Suppose it is a simple alkene. Now it is treated with the Bayer's reagent, and the simple answer is corresponding 1,2 dihydroxyalkane. So it is also called vicinal diol. Vicinal diol, also known as penacol. Also known as penacol. And in the presence of Bayer's reagent, this reaction is syn hydroxylation. This reaction is syn hydroxylation. Therefore here it is a double bond, and which is trans isomer. Which is trans isomer. And we know that trans isomer anti-addition meso or trans addition anti-addition, trans isomer anti-addition erythro. Trans addition syn, trans compound syn addition racemic, simple racemic, or trans compound syn addition threorasmic. So here we should write threorasmic. So threo means how to write the answer? Here CH3 and here pH. CH3 group and benzene group. Now here CH3 and pH. Okay. Now erythro and threo. Erythro means the same side, threo means opposite. So it is a trans compound. It is a syn addition. Therefore we get corresponding threorasmic mixture. We get corresponding threorasmic mixture. So here simply threo means both OH groups are opposite side. Both OH groups are opposite side. And the remaining groups here hydrogen, hydrogen, two hydrogens. So it is our final product. So we get corresponding threorasmic mixture. Now this mixture treated with MnO2. This mixture treated with MnO2, and we know that MnO2 oxidizes only allylic alcohols or benzylic alcohols. MnO2 oxidizes only allylic and benzylic alcohols. Now here this part is benzylic alcohol part and this part is benzylic alcohol part. Therefore we get corresponding product CH3 hydrogen OH C double bond O pH. Next compound CH3 OH hydrogen C double bond O pH. So here it is a oxidized part. It is a oxidized part. And this overall mixture is again it is a one chiral center, it is another chiral center, and the overall solution is again racemic mixture. Racemic mixture. So the final answer is these two compounds. The reactant has two functional groups. One is ketone, one is carboxylic acid. When it is treated with one equivalent of B2H6 with acetic acid presence, so here one functional group is ketone, another function is carboxylic acid, and we know that B2H6 is highly reactive for carboxylic acid. B2H6 is highly reactive, highly selective for carboxylic acid. Therefore here ketone reduction should not be considered. Only acid will be reduced to primary alcohol. Carboxylic acid will be converted to primary alcohol. Now this product is treated with NaBH4. NaBH4. And definitely NaBH4 do not reduce alcohols, but NaBH4 sodium borohydrate attack on the ketone, pi bond will be shifted, therefore nucleophilic addition, and the final product is O minus and CH2OH. And after acidification, if acidification is not given, granted we can take OH and CH2OH. And we know that NaBH4 do not reduce acid, ester, amide, cyanide, nitro, and epoxide. So these functional groups cannot be reduced by NaBH4. Cyclic ester, it is also called lactone. Cyclic ester also known as lactone. When lactone treated with LiAlH4, lithium aluminum hydride, so from this we get H minus. So H minus attack, leaving group will leave, and finally it gives corresponding aldehyde. Now this aldehyde again react with H minus, pi bond shifted, and corresponding product is O minus and O minus. and after acidification the corresponding products are OH and OH. So this is a carboxylic ester reduction with lithium aluminum hydride. Now it is treated with excess of PCl5. It is a primary alcohol. It is a primary alcohol. When alcohol treated with PCl5 through SN2 mechanism, in place of OH, we should write chlorine, alkyl chloride, and POCl3 plus HCl. So these are the reactants and products. Now similarly here excess we are taking, therefore primary alcohol, and the corresponding product is chlorine and chlorine dichloro compound. So it forms through SN2 mechanism. It is a carboxylic ester. When carboxylic ester treated with lithium aluminum hydride, so it is a carboxylic ester treated with the lithium aluminum hydride H minus. So H minus attack, leaving group will leave. Therefore we get corresponding CH3 C double bond OH, and the leaving group is CH3 CH2 O minus. Again it react with another H minus because it is aldehyde. So H minus react, pi bond shifted, and corresponding product is CH3 CH2 O minus. So here we are having 1 mole of CH3 CH2 O minus, another mole of CH3 CH2 O minus. Now if I consider acidification granted, I will get corresponding alcohol. Now this alcohol treated with BF3 and CH2N2. So in the presence of BF3, here CH2 minus take the proton from the alcohol in the presence of BF3. It gives finally CH3 CH2O minus and CH3N2 plus. So CH2N2 is diazomethane. So with diazomethane, acid base reaction takes place. Now it undergo SN2 type of reaction, and finally it gives corresponding methoxy product, and the leaving group is N2. It is purely SN2 reaction because it is a strong nucleophile and it is a primary. Strong nucleophile and primary SN2 reaction takes place. Finally we got corresponding propane and N2 gas. The reactant has two alcohol groups. Now it is treated with one equivalent of acetic acid. This compound name is acetic acid. And we know that when alcohol treated with the acid, the basic reaction is carboxylic acid when treated with the alcohol in the presence of H plus. So the general reaction is lone pair attack, leaving group will leave, and corresponding carboxylic ester will form. And we know that rate of esterification indirectly proportional to steric factor of alcohol and also indirectly proportional to steric factor of carboxylic acid. In case of benzylic carboxylic acid, directly proportional to positive charge on the carbon, like these kind of compounds if they are present. So here if you observe, it is primary carbon, it is tertiary carbon. So this is less sterically crowded, and it is more sterically crowded. That's why this nucleophile attack on the carbonyl carbon, leaving group will leave based on this point. Therefore the corresponding product is tertiary alcohol, it is not participated, primary alcohol participated, and corresponding ester is formed, carboxylic ester is formed. Now it is treated with benzoic anhydride. It is a benzoic anhydride. Again, if you see the benzoic anhydride, it is a leaving group. So benzoic anhydride, it is a leaving group. So definitely our reactant should behave like nucleophile, because here leaving group is present, RCO leaving group. So we should look for the nucleophile, and here it is a nucleophile and it is also nucleophile. But because of resonance, it is a weak nucleophile and it is a strong nucleophile. That's why lone pair attack on this carbon, leaving group will leave, and finally the corresponding product is O C double bond O PH O C double bond O CH3. So this reaction is called as, it is also esterification and esterification, also known as Fischer esterification. This is our final product. The alcohol treated with SOCl2, but this alcohol is allylic alcohol, alpha, beta, gamma. When this kind of alcohol is present, when alcohol treated with SOCl2, SNI and SNI dash both are possible. SNI and SNI dash. First I will write SNI. In place of OH we should write Cl. So this is the SNI product. To write SNI dash directly, we should shift the double bond here and write corresponding product like this: alpha, beta, gamma. Alpha, beta, gamma. So here the chlorine attached to the gamma carbon, that's why it is a SNI dash. Among SNI and SNI dash, SNI dash is major. Among SNI and SNI dash, SNI dash is major. Now these two compounds treated with moist Ag2O. So moist Ag2O means AgOH. So if I see the general reaction, alkyl chloride treated with Ag plus, it forms R plus by losing the Cl in the form of AgCl, and it will react with the corresponding nucleophile OH minus and forms alcohol. So this is a general reaction. Similarly, in this case also, if the first compound loses leaving group, it forms C plus. Second molecule loses leaving group, forms corresponding C plus. Now these two are resonance structures. Now these two react with the OH minus and corresponding product formed. And it is our corresponding final products. And among these two, it is a stable alkene. Therefore it is major. In this case, both are giving the same carbocation because of resonance. And finally, you are getting two products. Among these two, we are considering stable alkene as major product. The secondary alcohol treated with NaBr and H2SO4. So when alcohol treated with NaBr in the presence of H plus, primary SN2 are no reaction. Secondary and tertiary alcohol prefers SN1 reaction. Since it is a secondary alcohol, so it loses first H2O in the presence of H plus. After that, migration takes place. Now this migrated carbocation reacts with the OH minus and a corresponding product will be formed like this. So this is like SN1 mechanism. In the presence of H plus, secondary alcohol forming the carbocation, and carbocation undergo migration, and finally it is giving the corresponding substituted product with the OH minus. So this entire mechanism is SN1. Now this alcohol treated with CH3O minus, Na plus and CH3OH. And here CH3O minus is strong base and less bulky base. Strong base and less bulky base. And the reactant not supporting even CB mechanism because beta position, it is a alpha position, it is a beta position, it is a beta position. So here at beta position there is no minus R group, therefore even CB not possible, only E2 possible, only E2 possible. And here of course not OH minus, here Br minus, so Br minus attached, it is a Br, please correct it, Br. So alkyl bromide treated with the CH3O minus, this reaction is Williamson's reaction. Williamson reaction. In the Williamson we are expecting, because of strong basic nature, we expect SN2 and E2, and we know that one of the reactant is tertiary, therefore E2 is major. E2 is major. So SN2 product looks like this. It is a SN2 product. Next, E2 type elimination. So these are the products from the elimination. E2 mechanism. Now here SN2 and E2, because of tertiary carbon in Williamson ether synthesis, because of tertiary carbon, elimination is major. Elimination is major. Now among these two products, because of less bulky base, stable alkene is major. Because of less bulky base, stable alkene is major. Okay. Now the reactant has two pi bonds, two alkenes. Now it is treated with the Bayer's reagent called alkaline KMnO4. It is a Bayer's reagent and it follow syn hydroxylation. Therefore, because of syn hydroxylation, less sterically hindered alkene will be oxidized and we get corresponding vicinal diol and corresponding glycols, and this reaction is known as syn hydroxylation example. This reaction is an example of syn hydroxylation. Now it is treated with oxalic acid. Now it is treated with oxalic acid in the presence of H+. So immediately we should think like it is an alcohol and it is acid. When acid plus alcohol both are present, we expect esterification. We expect esterification. So in esterification what happens? Nucleophile attack, leaving group will leave. Nucleophile attack, leaving group will leave. And finally the corresponding product is C double bond O, C double bond O and corresponding ester. So this is our final product. So ఇక్కడ మనకి కార్బాక్సిలిక్ ఎస్టర్ ఫామ్ అయింది, ఇక్కడ మనకి కార్బాక్సిలిక్ ఎస్టర్ ఫామ్ అయింది. So because of these arrow marks you can understand. So this reaction is known as esterification. Secondary alcohol treated with K. K means potassium. Like sodium, we are taking potassium. Potassium and alcohol has acidic proton with respect to metal, therefore loses proton in the form of O minus and K plus and loses H2. Now here the interesting point is, it is a chiral center above the plane and it is also chiral center above the plane only. So both are above the plane. That's why it is a retention in configuration. That is retention. Now it is treated with CH3OTS and it is alpha carbon. There is no beta proton, we are having only alpha proton. Now here it is a good leaving group. Therefore, O minus attack at this carbon, leaving group will leave through SN2 reaction, and this reaction is known as Williamson ether synthesis. Williamson ether synthesis. Therefore, the corresponding product is above the plane OCH3. Therefore, overall reaction also retention in configuration. Retention in configuration. Chiral center above the plane, chiral center above the plane, chiral center above the plane. So with respect to that leaving group and the nucleophile positions, it follows retention in configuration. Secondary alcohol. It is a secondary alcohol treated with TSCl. So TSCl means tosyl chloride. So simply here what happens, lone pair attack on the tosyl group, leaving group will leave, and finally we get corresponding OTS and HCl, H plus and Cl minus. So to remove this HCl, we are adding pyridine. To remove this HCl, we are adding pyridine. So pyridine remove the HCl in the form of salt, pyridinium chloride. Pyridinium chloride. So మనం ఇక్కడ బేస్ ఎందుకు యాడ్ చేస్తామంటే హెచ్సిఎల్ని రిమూవ్ చేయడం కోసం. హెచ్సిఎల్ని రిమూవ్ చేస్తే the reaction will progress in the forward direction. Now if I focus on the chiral center, the stereo not changed, below the plane OH, below the plane OTS. Therefore it is retention in configuration. So chiral center stereochemistry not changing. Now it is treated with CH3COO minus Na plus, sodium acetate. It is called sodium acetate. And sodium acetate is strong nucleophile and OTS is good leaving group. Good leaving group and strong nucleophile, we expect SN2 type of reaction. Therefore here strong nucleophile CH3COO minus attack from the above the plane, leaving group will leave. Therefore the final compound is methyl is above the plane and here OTS is below the plane. Therefore nucleophile OCOCH3 above the plane. OCOCH3 above the plane. So it is our final product. The reactant has two alcohol groups. And the difference is one is less sterically crowded, another one is more sterically crowded. Now it is reacting with benzoyl chloride. Therefore we expect two types of reactions. O lone pair can attack and O lone pair can attack. When it is the case, RCO leaving group reacting with two different alcohols, and here less steric factor, more reactive. Therefore we have to consider this SN2 and we should not consider this SN2. And the corresponding product is above the plane, below the plane OCOPH. Less sterically hindered, this one. Therefore below the plane OCOPH. Now it is treated with copper 300 degrees Celsius. So it is a carboxylic ester with copper, there is no business. But here it is a secondary alcohol and copper. So this is oxidation. Secondary alcohol with copper, oxidation. Therefore secondary alcohol undergo oxidation and finally gives corresponding ketone and here ester group. It is our final product. It is our final product. So for oxidation of secondary alcohol, we can use copper, PCC, PDC, opener oxidation, Jones reagent, and CrO3 anhydrous medium. So we can use any one of these reagent to oxidize secondary alcohol to ketone. Now in this process, ester should not be affected. Alkene treated with bromine water. So when alkene treated with the bromine water, alkene react with the Br plus, leaving group will leave. So bromine form 3-membered ring. Now it react with the most available nucleophile, a tertiary carbon. Finally it gives corresponding product like this. So this overall reaction is anti-addition. This overall reaction is anti-addition. Now here with respect to stereo, if I talk, Br 3-membered ring and a nucleophile above the plane. Suppose 3-membered ring is formed above the plane and below the plane OH. So this is a reaction with the bromine water. Now it is treated with the AgNO3. Now it is treated with the AgNO3. So AgNO3, remove the Br minus completely. Remove the Br minus completely and form corresponding stable carbocation. Form corresponding stable carbocation. Now here we expect migration because this carbocation is more stable. So after migration, both molecules are converting like this. So both loses the Br minus, and then here hydride transfer takes place. This hydride transfer takes place. Finally, it forms corresponding stable C plus, and here lone pair resonance possible. Lone pair resonance possible, and the corresponding product is double bond OH plus. Now it loses a proton, and corresponding ketone will be formed. Corresponding ketone will be formed. So it is our final product. When alkene treated with the Bayer's reagent, cold alkaline KMnO4, it is also known as Bayer's reagent, and this reaction is syn hydroxylation. Syn hydroxylation. Therefore here two products are possible. OH below the plane, OH below the plane, OH above the plane, OH above the plane. It is a syn hydroxylation. Now it is treated with PCC. You can use PDC. You can use copper. You can use CrO3 anhydrous medium. CrO3 anhydrous medium. So like this we can use opener oxidation, Fenton's reagent. We can also use NBS. We can also use X2 plus OH minus, X2 plus CO3 minus 2, X minus plus XO3 minus. We can use any one of these reagent. So here what happens, secondary alcohol undergo oxidation, tertiary alcohol will not be affected. Therefore the corresponding product is ketone, OH above the plane, methyl below the plane, plus another compound, ketone, OH below the plane, and methyl above the plane. So when this undergo oxidation, it forms corresponding oxidized product, and this compound undergo oxidation, corresponding product undergo oxidation. Epoxide treated with sodium azide, NaN3. It is a sodium azide. Now here N3 minus is strong nucleophile, and strong nucleophile epoxide primary greater than secondary greater than tertiary. Now the reactant, it is a secondary carbon, it is a tertiary carbon. So strong nucleophile attack at secondary carbon, ring opening takes place. Now the corresponding product is O minus and N3, and I am considering acidification granted because nothing is mentioned. Therefore corresponding tertiary alcohol and azide. Now it is treated with the H2PD, and H2PD is reducing agent, and here the reducible functional group is alcohol cannot be reduced, but N3 RN3 can be reduced to RNH2. RN3 can be reduced to RNH2. Therefore here the corresponding product is tertiary alcohol, and N3 is converted to NH2. N3 is converted to NH2. So it is a catalytic hydrogenation. Epoxide treated with the ammonia, and which is a strong nucleophile. Therefore when strong nucleophile react with the epoxide, we have to follow primary, secondary, tertiary. Therefore it is a secondary carbon, it is a tertiary carbon. N lone pair attack at secondary carbon, ring opening takes place. Now it is treated with the HNO2. Now it is treated with the HNO2. And we know that the basic reaction is when RNH2 treated with the HNO2, it is a aliphatic primary amine. Aliphatic primary amine. So we have to write down in place of NH2, we should write N2 plus. We have to remove the N2 plus and write down the C plus. So similarly here also we can expect by losing NH2, it forms initially N2 plus. Now it loses the leaving group N2 gas and form carbocation. Now here two possibilities we can expect, because stereo is not mentioned clearly. One is, suppose methyl is migrated. Methyl migration takes place. So it is our corresponding product. So this methyl group is migrated here. Now here lone pair resonance possible, and after removal of proton, corresponding product is ketone like this. Another possibility is, if you observe clearly, another possibility is ring contraction. Another possibility is ring contraction. Even at that time also corresponding octet is possible. Now because of lone pair, it loses proton, and finally it gives corresponding product cyclopentane and double bond OH plus. Now it loses a proton and gives corresponding ketone. So here stereo is not mentioned of the reactant. Therefore 6-member ring ketone and 5-member ring ketone both are possible. Now among these two, we know that 6-member ring is more stable. Therefore it is a major product. 6-member ring is more stable. That's why it is a major product. Acetophenone. The structure of acetophenone is benzene, C double bond O, CH3. Acetophenone. Acetophenone treated with Grignard reagent PHMgBr. It is a Grignard reagent, and pH minus is nucleophile, and we know that aldehyde ketones undergo nucleophilic addition. Therefore, corresponding product is like this. So it is a added nucleophile. Now it react with the dilute H plus. O minus take the proton from the H plus, and finally it gives corresponding tertiary alcohol. Tertiary alcohol. Now it is treated with HI, hydrogen iodide. So it is a tertiary alcohol. So tertiary alcohol reacted with HI. So HI means H plus and I minus. Therefore primary SN2 type of reaction, secondary and tertiary SN1 type of reaction. Primary SN2 type of reaction, secondary and tertiary SN1 type of reaction. Therefore since it is a tertiary, so it follows SN1 mechanism, and initially it forms stable carbocation, and here ring expansion migration not possible. Now it reacts with corresponding I minus, and finally it gives corresponding tertiary iodide. Tertiary iodide. So here two mechanisms are involved. First one is nucleophilic addition, second one is nucleophilic substitution. Alcohol POCl3 pyridine. When alcohol treated with the POCl3 and pyridine through E2 mechanism, dehydration takes place. Through E2 mechanism, dehydration. That means the product is alkene. The product is alkene. For example, here CH3CH2OH. For example, if it is treated with the POCl3, lone pair attack on the phosphorus, Cl will leave, and finally it gives corresponding CH3, CH2, O, P double bond O, Cl, Cl. Now it is a leaving group, alpha and beta. Now pyridine act as a base. So through E2 mechanism, base remove the proton, leaving group will leave. Finally it gives corresponding alkene. So this is the dehydration mechanism, and E2 mechanism is anti-elimination. Therefore in the given question also, it is above the plane, it is below the plane. Now it is treated with the POCl3 and pyridine. So definitely E2 mechanism possible. Alpha leaving group, beta proton. But here this proton is above the plane. So at this position no elimination. But here one proton is below the plane, one proton is above the plane. So whatever we have explained here, so through that mechanism, here dehydration takes place, and corresponding product is alkene. Alcohol POCl3 pyridine through E2 mechanism, dehydration takes place. To this compound we are adding H plus H2O. When we add H plus, alkene react with H plus, it is electrophilic addition. So form stable C plus based on number of hyperconjugation. It is a stable carbocation position. Now it reacts with the corresponding water molecule. Finally the product is water can attack on the C plus above the plane as well as from the below the plane. The reactant has alcohol and ether. So when we add SOCl2 and pyridine, we know that when alcohol treated with SOCl2 and pyridine, SOCl2 and pyridine, through SN2 mechanism, alkyl chloride will be formed. Through SN2 mechanism, alkyl chloride will be formed. So here also it is an alcohol, primary alcohol, react with SOCl2 in the presence of pyridine. It also give corresponding alkyl chloride. Now this alkyl chloride treated with a magnesium. So magnesium is a metal. So ether won't react with the metals. Ether won't react with metal, but alkyl chloride react with metal. We know that when Rx treated with the magnesium, it gives corresponding R minus MgX plus. Therefore here it forms corresponding Grignard reagent. It forms corresponding Grignard reagent. Now it is treated with corresponding epoxide, and it is a strong nucleophile. Strong nucleophile react with epoxide. It follows SN2 mechanism. That means primary greater than secondary greater than tertiary. Therefore nucleophile attack at primary carbon, ring opening takes place. Ring opening takes place. So this is our added nucleophile. It is the nucleophile. Now after acidification, finally it gives corresponding alcohol. So it is a nucleophile. So through SN2 mechanism it is added. So first one is SN2 reaction, second one is Grignard formation, and third one is again SN2 reaction. Alkene treated with B2H6. Alkene treated with the B2H6. This reaction is known as hydroboration. This reaction is known as hydroboration. So we know that in the hydroboration, more sterically hindered carbon will be connected hydrogen, and less sterically hindered carbon boron will be attached. It is a hydroboration. Now it is treated with the H2O2 OH minus. So this is oxidation. So here simply in place of boron, we should write simply OH group. In place of boron, we should write simply OH group. Now it is treated with the tosyl chloride. Tosyl chloride is para-toluene sulfonyl chloride. So here what happens? Lone pair attack on the tosyl group, Cl will leave. So lone pair attack on the sulfur, Cl will leave. So this is entire group is tosyl group. So simply we can write corresponding OTS. And OTS is very good leaving group. And we know that OTS is good leaving group than I minus, than Br minus, than Cl minus. When compared to halides, OTS sulfonates are good leaving groups. Now it is treated with the tertiary butoxide, sodium tertiary butoxide, and tertiary butanol. So it is a bulky base, strong base and bulky base, and it is a very good leaving group. Therefore here E2 elimination takes place. Alpha, beta. Therefore more stable alkene and less stable alkene both are formed. But since it is a bulky base, most acidic proton, less stable alkene will be the major product, because bulky base can approach this carbon easily, less sterically hindered carbon easily. It can take the proton easily, but bulky base cannot take the proton here that much easily. That's why it is minor product and it is major product. So that's why it is a major product. So here the first reaction is hydroboration, oxidation, second reaction is nucleophilic substitution, and third reaction is elimination, E2. So the first compound is alcohol and ether. So when this reactant is heated in the presence of H plus, so we expect here alcohol dehydration. So lone pair attract the proton and it forms corresponding OH2 plus. Even though it is primary, in case of dehydration, C plus will form. In the case of dehydration, C plus will form. Now corresponding my ring expansion to get corresponding stable intermediate. And this can be written as 6-membered ring, oxygen positive. So because of octet, it is a stable carbocation. Now it loses proton and finally it gives corresponding product like this. So here it is a first reaction. The overall reaction is simply dehydration. Now it is treated with H plus and methanol. When H plus is added, alkene react with H plus. Alkene react with H plus, give stable C plus. Now the stable C plus react with the nucleophile methanol and finally it gives corresponding ether like this. So this is acetal. It is acetal. So here the first reaction is dehydration. Second reaction is electrophilic addition, because alkene react with H plus followed by nucleophile, electrophilic addition. The reactant has two functional groups. One is phenol functional group, one is alcohol functional group. When it is treated with the HBr, we know that benzene containing leaving group do not react with HBr, but this HBr react. Since it is a primary benzylic, it follows SN1 mechanism. Therefore here the corresponding product is first OH we have to remove in the form of H2O. Because of addition of H plus, it forms stable C plus. Now it reacts with the corresponding Br minus and finally we get corresponding alkyl bromide. Now it is treated with aqueous NaOH, 1 equivalent. When 1 equivalent is added, we are expecting two types of reactions. One is with this one acid base reaction, and with this one we can expect nucleophilic substitution reaction. But acid base reaction is fast, that's why we are adding only 1 equivalent. Therefore the corresponding product is corresponding phenoxide derivative. We are adding only 1 equivalent. Acid base reaction takes place fastly. Now it reacts with CH3OTS. We know that OTS is a good leaving group and O minus is nucleophile. Therefore nucleophile attack, leaving group will leave, SN2 reaction takes place and corresponding ether will be formed. It is simply Williamson ether synthesis. The first reaction is nucleophilic substitution, SN1 reaction, and the second reaction is Williamson ether synthesis, SN2 reaction. Here SN2, here acid base. The reactant has ether functional group. Now the ether treated with HBr and we are using HBr excess. So here what happens, lone pair attract the proton and corresponding oxonium ion will form. Now we know that Br minus will attack, but Br minus cannot attack at this carbon because benzene connected to leaving group, reaction won't takes place. But at this point reaction takes place. Since it is primary, we are following SN2 reaction. Therefore corresponding SN2 product is corresponding SN2 product is like this. It is corresponding SN2 product. Now it is treated with 1 equivalent aqueous NaOH. 1 equivalent aqueous NaOH. So here phenol is acidic. 1 equivalent aqueous NaOH base. Therefore, acid-base reaction takes place and corresponding phenoxide will form. Now, if I observe this reactant, it is a nucleophilic part or basic part, and here we are having primary carbon. Since phenol is more acidic than water, if any compound more acidic than water, the corresponding conjugate base is nucleophile. Therefore, nucleophile attack internally and leaving group will leave. Therefore, it is a intra-Williamson ether synthesis. The product is ether. So, this is also intra-Williamson ether synthesis. Williamson ether synthesis. The first reaction, nucleophilic substitution. Second reaction, acid-base reaction, and followed by intra-SN2. Alcohol treated with SOCl2. It is a secondary alcohol, and secondary alcohol treated with SOCl2. We know that when alcohol treated with SOCl2, it follows SNI mechanism, and SNI involves retention in configuration. Therefore, here OH is right side, and we get the final product OHCl is right side. So it is a retention in configuration. Now it is treated with KCN in polar aprotic solvent dimethyl sulfoxide, and CN minus is ambidentate nucleophile, and it is a strong nucleophile. Since it is a secondary, we follow SN2 reaction. Therefore, CN minus attack from the backside with respect to leaving group. Therefore, the corresponding product is PH, CH3, and here cyanide group and hydrogen inversion. Of course, we know that since it is an ambidentate nucleophile, nitrogen also can attack from the backside, and it gives corresponding isocyanide. So cyanide and isocyanide. So this reaction is SN2. Therefore, it involves finally Walden inversion. That means with respect to leaving group, the nucleophile attack from the backside. So first one is SNI, second one is SN2. Alcohol treated with sodium. When alcohol treated with the sodium metal, it loses proton in the form of H2. Now it is a alkoxide. Now if I observe the stereochemistry of chiral center, here it is observed that retention in configuration. Stereo not changed. Now it is treated with CH3, CH2, Br, alkyl bromide. So here two types of reaction possible, because alkoxide can act as strong nucleophile and strong base. When it is strong nucleophile, SN2. When it is strong base, E2. Therefore here, suppose SN2 reaction takes place, the corresponding product is like this. So it is a SN2 related product. Suppose if O minus remove the proton from the beta carbon, and it gives corresponding product alcohol plus CH2 double bond CH2, and it is a E2 example. Now here in SN2, in SN2 this carbon stereo not changed. Therefore with respect to this carbon it is again retention. జనరల్లీ SN2 రియాక్షన్లో ఇన్వర్షన్ మాట్లాడతాం, కానీ ఇక్కడ రిటెన్షన్. ఎందుకంటే ఇన్వర్షన్ మాట్లాడేది ఎప్పుడు కూడా ఏ కార్బన్ దగ్గర రియాక్షన్ జరిగిందో ఆ కార్బన్ దగ్గరే మనం మాట్లాడాలి. సో ఎట్ దిస్ కార్బన్ నో డౌట్ ఇన్వర్షన్, బట్ ఎట్ దిస్ కార్బన్ స్టీరియో నాట్ చేంజ్డ్. If chiral center is present, we should talk about only chiral center. That's why here the best answer is retention in configuration, because it is a chiral center. Here the corresponding cycloalkene treated with a Bayer's reagent called alkaline KMnO4. It is known as Bayer's reagent. We know that when alkene react with the Bayer's reagent, this reaction is syn hydroxylation. Above the plane OH groups plus below the plane OH groups. So the overall reaction is syn hydroxylation. Now it is treated with the oxidizing agent PDC, pyridinium dichromate. So here we know that tertiary alcohol do not undergo oxidation, but secondary alcohol undergo oxidation. So because of this compound, because of oxidation, we get corresponding product like this, secondary alcohol oxidation. Now this product will be oxidized to corresponding ketone. So this is our final product. So here first one is syn hydroxylation, oxidation, second one also oxidation.